Okay, so let us talk about the rest of these in that second row. Carbon, nitrogen, oxygen, fluorine, and neon. So I know that I still have the same core that I had before. So all of these are still going to have what I had in that first row. So that one S2, and I'm going to go ahead and write that down. And that means that I'm always going to have the helium core. And so I'm going to write that for everything except neon. And I'll explain why in just a second. Okay, just slip it. Now, carbon is going to be based on what we had before, so that 2s2, 2p1, but I'm going to add an additional electron. So when I'll have the 2s2, that stays. That's exactly the same. Add the next electron into that 2p because I can have 2 electrons in there. So 2p2. You have that 2s because that's full, so I can't put any more in it. And then that 2p2. Okay. By that same token, I have 2s here and 2s here. Okay. Nitrogen now has 3 electrons in the p. So p can contain a total of 6. So I have 2p3. Now it's in us and we actually have 1 in each of the p orbitals at this point. We don't show that here. Okay, so I now have 3 of them in the p's. So 2p3. Yeah, oxygen, we have that 2s2. That's right, it's 2. And now I've put 4. So 1, 2, 3, 4 electrons in that p. So 2p4. When we talk about fluorine, we've done 1 more. Now I have 5 in that p. So again, I have my 2s that goes here and 2p5. 2s2, 2p5. Now when I get to neon, I still have 2s2. Well, that's still true. And now I've got 2p. 1, 2, 3, 4, 5, 6. So 2p6. That means that I could do helium, 2s2, 2p6, or I could just list this as Ne. That is acceptable. Oh, awesome. Okay. You got that, Coolio? So that takes us through all of these. So 1s2, 2s1, 1s2, 2s2, 1s2, 2s2, 2p1. And again, as we're filling, we have 2p3, then we have 2p4 where we're pairing, and then all the way down to the 2p6 where everything is paired. Cool. Awesome. So I always have what I had before. I have 1 additional electron, and the question becomes, where does it go? Okay. And as long as you're still in the same block, it's still going in the same place. The only time it'll go in a different place, with few exceptions, is if you're in a new block. Yeah. That brings us through our electron configurations all the way up to neon. So now I want you to do, since you've done 1 through 10, do 11 and 12. So I want you to take some time and do 11 and 12. Okay. So Na, we're in that third row. So I have everything I had for Ne. Remember that my noble gas configuration for Ne was everything I had for He, which was 1s2. And then I got that 2p, or sorry, 2s, because I had to go into the S block first. And that 2s was full. And then I went across to the 2p, and that was full. So 2p6. And now I'm looking at 3, because I'm in the third row. I'm in the S block. And there's one additional electron in that S block. So that's a 3s1. Nearest noble gas is that neon that I just did. And then everything beyond that is that 3s1, additional electron that I just put in. Okay, so that's my noble gas configuration. When we talk about our Mg, you're still talking about that core that I had before. So 1s2, 2s2, 2p6. 2, 2s2, 2p6. And again, that comes from 1s containing 2 electrons, 2s containing 2 electrons, and then 2p containing 6 electrons. We then come down to the third row. We have an S-type orbital that now has 2 electrons in it. So 3s2. We still have a neon core. And we now have 3s2. Now, notice that I'm doing this full electron configuration, and I keep saying 1s2, 2s2, 2p6. Why am I doing it? Because it helps me to remember that it is 1s2, 2s2, 2p6. I got very good at those noble gases because if I could rattle off their electron configurations fairly quickly, then I wouldn't have to worry about what is the electron configuration of that noble gas. Even though I knew I could write this, if they ever asked me for the full one, then I knew exactly what it was. Now, again, is it necessary? Absolutely not. But it becomes habit for me. So 1s2, 2s2, 2p6. And then we get, I mean, if I were to do the next one, it'd be 1s2, 2s2, 2p6, 3s2, 3p6. And again, I can see that. 3s2, 3p6. Okay, so I can tell from looking at the table, just based on where that thing is, what its electron configuration is going to be. It becomes very easy once I know the order in which those things fell to be able to tell what its configuration should be. As you write them, this should become more familiar to you. I understand that it may sound like Greek right now. I get it. It takes a lot of practice. I totally understand that. But don't forget that if you go to this rsc.org periodic table, it will give you those answers so that you can check your work. Okay? All right. Now, let's continue. Condensed electron configurations, noble gas notations. We've actually been talking about this. So we put the noble gas in brackets, then start the electron configuration where the noble gas left off. So we've been doing that. Now, we're going to get into a point where we want to talk about the transition modes. Okay, so I am saying, all right, we know how to do sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon because it's 3s2, 3p6, and if we're not there yet, then it's 3s2, 3p4, which is sulfur, right? Because 4, 1, 2, 3, 4. So that's sulfur. Okay. But when we get to the next row, so I've filled my argon core, And that's what I see here is this argon core. And then I fill my 4s. That's what I would expect because it now comes in this next row. I fill that 4s. And then I start filling the 3D, right? Because that's the next thing that fills. And they write the 3D in the middle, okay? You can do that. And there's debate over which way it should be done, okay? Some people write the 3D first because it's on the inside. Some people write the 4s first because it's lower in energy. I write the 4s first because it's lower in energy and it filled first. So whichever way you do it, that's up to you. And everything looks fine. 4s2, 3D, 4s2, 3D1, 4s2, 3D2, 4s2, 3D3, 4s1, 3D5. What the heck? 4s2, 3D6, 4s2, 3D7, 4s2, 3D8, 4s1, 3D10? So there are some weird things that have happened there. Notice we go 1, 2, 3, 5, and 5. And then we've got 6, 7, 8, 10, and 10. And that's what I want you to understand. Now remember, what did I say? We get additional stability when it's half full or when it's completely full. So if I get to this point and I need to put in one more electron, it would either be 4 across, which is okay, and completely full, or I can put 1 in here to be that 4th one and take 1 out of here, and then both of them are half full. And that's more stable. So we end up with chromium and copper. So this column, these guys right here, and these guys right here are those exceptions. What I need you to understand is that anything that is below the one above it will have the same electron configuration. So let's talk about that for a second. We kind of skipped doing sulfur, which is 16. So let's talk about sulfur. We did oxygen, and oxygen was the noble gas before, and that was helium. And then we have 2s2. There's 2p, and there's 1, 2, 3, 4 in the p, right? Now sulfur is another row down, so that means we're going to have the neon core. And then we're in 3, and that one's full, and then 3p, and because it's below it, it has the same number of p electrons, 3p4. So what we're starting to see is that as when we look at the table, the electron configurations for the things that are in the same column are pretty much the same. That, that outer bit is the same. And I said that the outer bit was what determined the chemistry it could do, right? And because it's what determines the chemistry that it can do, that was how we decided how it was decided that they should go in the order that they are. Because we put things in groups because they have the same chemistry. Okay. So that's why they're in the places that they are. Right? Because they have the same properties. And that's based on their electron configurations. Oh. So I need to understand their electron configurations because that will tell me what should go where. And it tells me a lot about their chemistry. Right? So these are not just esoteric things that we're making you do. It's important to understand what they are so that we can understand what they can do. Right? And really, we're focused on how many electrons are in this outer bit. Again, we'll talk about how that's important later on. So there are some exceptions. I love to ask about the exceptions. Okay, so chromium, copper, I love to ask about them because they are weird, all right? So I love to ask about them because why do they do that? And I typically ask, why do they do this? So I'll ask you to write an electron configuration for this. And then I'll say to you, do you notice anything about this electron configuration? Is this what you would expect it to be? That kind of thing. And that's kind of a hint that maybe it's not what you, like everything else, but it's that kind of thing. Okay? Now, I won't ever ask you about these, but I want you to understand that we end up with the same kinds of things happening here. It happens in the D's and it happens in the F's. So we're pulling from that S to get that half full, completely full situation, right? So we end up with the same exceptions. And that's exactly why we do it. Like I said, I won't ask you about these, but we do have those same exceptions, okay? Cool with that. Hope so. So like I said, I won't ask about these, right? But you should be able to tell me what order they fill in, because again, the table tells you. So you should be able to tell me that it's 1s, 2s, 2p, 3s, 3p, 4s, 3d, because it's n minus 1, 4p, 5s, 4d, 5p, 6s, and then this one is going to be 4f, because this is the F block. This is the one that goes down here. So that's 4f, and it's n minus 2, remember? And then it's 5d, and then it's 6p. So you should be able to answer that is the orbital that they fill in. And that typically occurs in like multiple guess. I'll say to you, which of these is the correct orbital filling order kind of deal, to make sure that you understand what that orbital filling order is. Okay? Questions about that? All right. That takes us to the end of the lecture portion. I want you guys to go and do the practice. I want you to make sure that you understand how to write an electron configuration in both the full form and the noble gas form. I want you to go into ALEKS and answer any of the questions that they ask you. And if you're having problems with it, and of course the D12 practice as well, if you're having problems with it, we need to talk about that. Because again, it's very important that we be able to do this so that we can talk about things as we start talking about the chemistries that were involved. Okay? And I'm going to put this together for you so that we can get this posted, and I will talk to you guys soon. Thanks for being with me. I'll talk to you soon.